All right. So the last of this ACT stuff is about imaginaries and vectors. So we're going to knock those out together. Imaginaries are basically part of the complex number system, A plus BI, where A is the real part and BI is the imaginary part. I is the square root of -1. Your pattern is I or I. You can say that's the square root of -1. I squared is -1. I cubed is -I, and I to the fourth is 1. Okay. And then I to the fifth would be I to the sixth would be -1, I to the seventh would be -I, and I to the eighth would be 1, and it goes on like that. The only things you need to be able to do for complex numbers are add, subtract, and multiply. So when you add and subtract, you add the real parts to the real parts and the imaginary parts to the imaginary parts. And basically what you do is it's like adding like terms, okay? It's kind of like your I is a variable. Even though it's not a variable, it's an imaginary. You distribute when you multiply or you use FOIL or the box. And you don't forget that I squared equals -1. That's important. If you're doing this in your calculator, whether that's you change your mode to A plus BI or complex. The ones on your phone, it says complex instead of A plus BI, and you use the I over the decimal, so the second period, okay? So I'll do a couple of these by hand, and then I'll do them definitely by in your calculator. So if you're adding these, you just do 5 plus -2, which is -3, because those two go together, and then 7i and 3i is 10i. That's it, like terms. If you were subtracting, you would have to do distribute and then do it, okay? If you were multiplying, you distribute. So this would be 26i minus 18i squared. Well, remember I squared is -1. So this is basically 26i plus 18. And normally the real part is written first. If you do this in your calculator, it's always going to give the real part first. If you did this one by hand, you would use a box. So you do 3 plus 4i, 8, and -5i. So 3 times 8. 3 times 8 is 24. 4i times 8 is 32i. -3 times -5i is -15i. And 4 times -5 is -20, and I times I is I squared. Remember, I squared is equal to -1. So when you cross this out, that changes the sign here to a positive. I'm just going to change the sign here to positive, okay? So now we have 24 plus 20 is 44, plus 32i and -15i is 17i, and that'll be your answer. Now, if we're doing this in our calculators, we would go to the mode button here. See right here where it says A plus BI. In your calculate menu, it says complex. On your calculate for Android, there's like multiple tabs here. Just make sure you're on the one that says TID4 in the mode button, and it does say complex. So we're going to go down here, and we're going to change it from real to imaginary. Just hit enter on it there, and I'm going to clear this out so you got a clean screen here. And then you basically put in exactly what it says. So parentheses 5 plus 7i plus -2 plus 3i. So parentheses 5 plus 7i plus parentheses. Oh, that should be an I. I don't know why the I didn't come up. So I is down here. So second and the period makes I. Okay. And then -2 plus 3 second period makes I. And when we add those, you get what we got, 3 plus 10i. So the next one is parentheses 9 minus I minus 1 plus I. So your answer is, it would help if I put in the right problems. Sorry about that, y'all. So this problem should be, let me fix this problem here. I'm gonna pull it back up here. 9 minus I, and it should be 4 plus 6I. I don't know what's going on. 4 plus 6I. Let's try that. That's the right problem. So 5 minus 7I goes here. Then we have negative 4 minus 3. It's like my buttons aren't working. Minus 2 plus 4I. So negative 6 minus 7I. Now, some of these you can probably do quicker. 5 plus 1 is 6. 6 plus 1 is 7. So 6 plus 7I. Let's double check this guy. So 2I. And let's do 13 minus 9I. So 18 plus 26I, which is what we got. We wrote it the other way around. But that's the same thing, right? 18 plus 26I, same thing. So again, this might be easier just do by hand. Negative 4 times 5 is negative 20. Negative 4 times 2I is negative 8I. But if you don't want to do it by hand, you can do it in a calculator. But these are a lot easier in your calculator. So let's go ahead and put these in our calculator. So 3 plus 4I times 8 minus 5. I make mistakes, so obviously you want to check me. So 44 plus 17I, which is what I got. So we'll put the next one in. Negative 2 minus 3I and 5 minus 2I. So negative 16 minus 11I. And 3 plus 2I times 3 minus 2I. So 3 plus 2I times 3 minus 2I is 13. Now, you'll notice the imaginary went away on this last one. And what these are called conjugates. And when you have a plus bi and a minus bi, when they're the same except one's one plus and one minus, the imaginaries go away when you multiply them. Okay? And that's a way to get rid of imaginary numbers. All right, so let's look at vectors. So when you're doing vectors, vectors are basically used in physics. They are we would do a whole lot more with these if we were doing pre-calc, but because it's just for the ACT, they only want you to be able to add, subtract, and scale and multiply. So I'm just going to give you some basic information. Vector is a quantity that has both magnitude and direction. Magnitude is the length of the vector, and direction is indicated by arrowhead and an angle, usually. This should be AI plus BJ. I don't know, I made a typo in there. The graph of the vector, this is the X portion is A and the Y portion is B. And so this would be vector AB. When you're adding vector V to vector W, this is what this looks like, vector V and vector W. You would just add the X components and then add the Y components. Same thing when you're subtracting, you subtract the X components and then subtract the X components and then subtract the Y components. When you have a scalar, remember a scalar is just a number, times a vector, you multiply the scalar times both things. So when you do these, r plus s is 3, negative 5, plus negative 2, 3. And you just add 3 plus negative 2 is 1. And negative 5 plus 3 is negative 2. So t minus u is 4, 1 minus negative 7, negative 6. So 4, let's distribute this negative through. So 4 plus 7 is 11, and 1 plus 6 is 7. 2 times s is negative 2, 3. So 2 times 2 is negative 4. 2 times 3 is 6. 4 times r is 3, negative 5. So that would be 12, negative 20. Negative times t, 4, 1, would be negative 4, negative 1. Negative 3 times u would be 21, 18. When you do 4s plus 2u, so you do 4 times negative 2, 3, plus 2 times negative 7, negative 6. So 4 times negative 2 is negative 8 and 12. And then 2 times negative 7 is negative 14 and negative 12. And you add the x's, which is negative 22, add the y's, which is 0, and that would be your answer. So same thing here, 3 times r is 3, negative 5, minus 5 times t, which is 4, 1. Now, the easiest way to do this is multiply the r, right? Multiply negative 5 times this and make this plus in between. So negative 5 times 4 is negative 20. Negative 5 times 1 is negative 5. Now you're just adding. So 9 plus negative 20 is negative 11, and negative 15 and negative 5 is negative 20. So negative 2 times negative 7, negative 6, plus 3 times 3, negative 5. So you get 14, 12, plus 9, negative 15 is 23, negative 3. And so that's all you'll do for vectors. And that's all you need to do for that homework assignment.